Hey guys, it's Michael here from FlySight. In this video, we're going to look at the new wind adjustment features in the FlySight Viewer. The first thing we'll do is we'll load a track. Now I've got my display set up here already. So in the top we have the usual plot view. In the bottom left I have the wind view, and then the drag polar, and on the right I have scoring. I'm going to show elevation in the plot view. I'm also going to show the horizontal and vertical speed. So I'll hit H and V. Let's take a look at the wind view. So the wind view is a plot of horizontal speed for every point in the track. When we move the cursor in the wind view, we'll also see those points highlighted in the other views, including the plot view on the top. And likewise, if I move my cursor in the top plot, we'll see that point highlighted down in the wind view. The wind view only shows the data that's in the current view on the top. So if we zoom in or out in the current view, you can see it affects what's visible in the wind view. We want to measure the winds using data from the climb to altitude. So the first thing we're going to do is we're going to zoom in from takeoff to the top of the climb. So I'll hit Z, and we'll zoom in to about that range. Now we can look down at the wind view, and if there are any parts of the wind view that don't seem to fit the circle very well, we can identify where they come from. So in this example, everything fits quite well, but for example, this little arm here seems to be coming from the top of the climb to altitude. So most likely up here, the plane was flying a little bit quicker, and likewise we can see some places where the plane probably was flying a little bit slower at lower altitudes. In fact, these lower altitudes we can eliminate quite easily. So what I'll do is I'll zoom in from about that point to the top. You can see that cleans up the wind view just a little bit. Once we have a good fit in the wind view, we can click the Save button, and that'll save the current winds, which are down in the bottom right of the wind view, to Preferences. So let's click the Save button. And anytime we want to see what we actually have saved, we can go to File, Preferences, and then change to the winds. And there's what we have saved. So of course, right now it's exactly the same as what's down in the wind view. Now that we've saved the winds, I'm going to zoom out and look at the whole record again. And in particular, I want to take a look at the horizontal speed during the climb to altitude. You can see there are times when the speed is very low, and there are times when it's high and low again. Most likely, that's because sometimes the plane was flying into the wind and sometimes it was flying downwind. Now that we've clicked the Save button, we can adjust for winds by going to the Tool menu and clicking Wind Adjustment, or we could just hit the W key. There's a red indicator in the top right that tells us the results are adjusted for wind. You can also see that the horizontal speed has flattened out quite a bit during the climb to altitude, and in fact in this case, even on jump run, the horizontal speed is pretty constant. We can flip back and forth between adjusting for the winds and not by hitting the W key, and those differences become a little bit more obvious. So there, no adjustments, there's a lot of variation in the speed, and here with adjustments, there's much less variation. So we've done a fairly good job of correcting for the winds, I think. Which results are actually adjusted for the wind? In the top plot, anything that depends on horizontal speed will change. So if we take a look at the left menu, things like the horizontal speed, the total speed, the course, the glide ratio and the dive angle, the acceleration, total energy, energy rate, and of course the lift and drag coefficients will change. Let's zoom into the jump itself. So I'll hit the Z key, and we'll drag over what appears to be the jump. The first thing I'm going to do is I'm going to mark the exit. So I'll hit the X key, and I always look for the exit where the horizontal speed suddenly drops. So I'll click here and we can see we've just picked the exit. So time 0 is now where I just clicked. Now let's zoom in a little more precisely onto the jump. I'll hit the Z key, and I'll click and drag from the exit to roughly the place where the horizontal speed starts dropping. Let's take a look at the drag polar now. So right now we're looking at the drag polar with the results adjusted for wind. If we hit the W key, we can see what it would look like without those adjustments. That's without adjustments, and that's with. Without adjustments, with. You can see that adjusting for the wind really focuses the drag polar. So instead of just having a scattering of points, we actually see really distinct lines. And what's interesting here is we don't actually see one single curve. It looks like we see 3 different fingers. We can move the cursor around in the drag polar to explore where these fingers might be coming from. So the top finger is coming from somewhere within the competition window. The middle finger comes from somewhere after the competition window. And the bottom one is coming from mostly the dive above the competition window. So why doesn't this look like just a single curve? The thing to remember is the assumptions that we made in the introduction to aerodynamics. The big assumption was that the airfoil is constant, but we just changed the angle of attack. And the airfoil is the cross-sectional shape of the wing, so how can we violate that assumption? One of the big things that we could do is, for example, if we drop our knees, we'll actually change the shape of the airfoil. So what we're looking at here are effectively 3 different airfoils using the same wingsuit in one jump. Down at the bottom, we have an airfoil that tends to reduce the amount of drag, and the jumper is using that while they're diving. Up at the top, we have an airfoil which tends to maximize the amount of lift, and they're using that in the middle of the competition window. So how do we fit this one? I would focus on the bottom and the top fingers. We're going to click and drag, and we'll try to put the minimum drag somewhere near the left edge of the points. We'll try to get the red curve passing roughly through the bottom finger and the top. Now we see some points that are scattered over on the right side. Those aren't too concerning. If you remember back to the introduction to aerodynamics, when the suit stalls, we expect to see points that are somewhere below the curve where drag is increasing much quicker than we would have expected. Next, we want to pick the maximum lift. And for that, we want to avoid being optimistic, but we don't want to be too pessimistic either. So we're going to try to pick a place where there are a lot of points, and probably a place that's close to the curve. As these points go away from the curve, we're looking more at a stalled condition. So I'm going to pick a place right around here just by clicking. All right, next let's take a look at scoring. I want to take a look at the distance scores. And in particular here, let's take a look at the effect of adjusting for wind. So I'm going to hit the W key to turn off adjustments. And you can see that distance score goes up. If I hit the W key again, the distance score comes back down. We'll see a longer distance without wind adjustment because in this case the jumper had a tailwind and we're subtracting that tailwind when we adjust. Let's quickly perform an optimization. Let's abort there and see what we've got. One of the biggest things I want to point out here is that when I hit the W key, the optimized results don't change. And the reason for that is that the optimized results depend only on the red curve. And we picked the red curve using results that were adjusted for wind. So we can compare the optimized results with the adjusted results from the actual jump. We can't really compare the optimal results with the unadjusted results. That's it. Thanks for watching. And as always, if you have any questions, please leave them in the comments below.